In this video lecture, I am going to be discuss about heat treatment of ferrous and aluminum alloys. What is heat treatment? Okay, so this is an introduction about the heat treatment process, which is a material processing techniques. In engineering, successful design depends upon the selection of materials having the most desirable properties for a given function. Hardness, ductility, toughness, formability, machinability, etc. are important properties of materials for their applications. Most of these engineering properties of metals and alloys are related to their structure. Mechanical properties can be changed by varying the relative properties of microstructures under non-equilibrium conditions. These changes in mechanical properties are achieved by a process that is known as heat treatment process. Definition of heat treatment. It is defined as an operation or combination of different operations involving the heating and cooling of metal or an alloy in solid state for the purpose of obtaining certain required structures and desirable properties or a combination of properties suitable for the particular applications. Objects of heat treatment. So heat treatment is carried out to achieve one or more of the following objects. To relieve the stresses set up in the material after hot or cold working in order to improve machinability. To improve mechanical properties like tensile strength, hardness, ductility, shock resistance, etc. To modify the structure of the material to improve its electrical and magnetic properties. To increase the qualities of a metal to provide better resistance to heat, corrosion and wear. To change grain size. To stabilize the structure against dimensional changes under moderate temperatures by successive heating cycle to a temperature just above the encountered ambient temperature. So steps of heat treatment steel. So this steel is heated above critical temperature called the austenizing temperature. During heating, the previous structure of steel is converted into austenite phase. So in this diagram, you can see this is a graph of temperature versus time. From A to B, this is a heating of the material. After reaching the austenite temperature, this is the austenite temperature, the steel is held at this temperature for some time known as holding or soaking period. So from B to C, this is for this particular time is known as soaking time at a constant temperature. Soaking results in the formation of homogeneous austenite throughout the entire cross section, and steel with homogeneous austenite is cooled to room temperature. So here C to D is cooled to room temperature. The cooling rate depends upon the properties required. So the angle between BA and AB dash, this angle is known as rate of heating and this angle is known as rate of cooling. So it is depends on the properties. Time, temperature and transformation means TTT diagram. So this is a TTT diagram, temperature of transformation degree centigrade versus transformation in time. Okay, so here there are two zones. One is beginning of decomposition and this curve is the end of decompositions. Okay. So between these two, you will get the different types of structures of the material. Coarse, fine, upper benite, lower benite, ferrite, martensite. Okay, so these different structure will be achieved for different mode of cooling. Time temperature transformation TTT diagram is extensively used in the assessment of the decomposition of austenite heat treatable steels. It is also known as S curve, C curve, Brains curve or isothermal transformation diagram. This diagram shows the relationship between the temperature and time for the transformation of austenite when the transformation occurs at the constant temperature, that is isothermal. The temperature of transformation controls the nature of decomposed product of austenite, which in turn decides the resultant properties of the steel. So here microstructure of steel before and after heat treatments. So this is a ferrite microstructure, cementite, perlite. So before heat treatment, these are the different structure of steel, but after heat treatment, these are the structures which is obtained using heat treatment process. Globules of trucite, okay, sorbite, martensite, which are the obtained structures. Here, this is a ferrite before heat treatment process, and after the heat treating, like water quenched, oil quenched, air cooled, furnace cooled, the achieved microstructures like martensite, very fine perlite, and coarse perlite. Now, heat treatment process. Depending upon the method of heating, the furnace atmosphere, the heating temperature, and the cooling medium used, and the properties desired, various heat treatment processes of steels are classified as follows: annealing, normalizing, hardening, tempering. Different type of tempering processes are there: maltempering, austempering, like this. And last one is case hardening, or you can say surface hardening. So in iron and carbide diagram, this is a part of iron and carbide diagram in which the temperature of the metal must be austenite temperature. So this is a austenite zone, gamma zone. And this range is the temperature range for normalizing, annealing. This range is for annealing, and this part is a range of hardening temperature. First, annealing process. So annealing may be defined as the heating the steel to a certain predetermined temperature, holding it at that temperature for a sufficient time to allow the necessary changes to occur, and then cooling slowly at a predetermined rate. The following objectives are achieved with annealing: to relieve internal stresses induced by previous treatment such as rolling, forging, casting, etc., to improve machinability, to soften the steel, to refine and homogenize structure, to remove gases, to induce stable structure, to improve mechanical, physical, electrical, and magnetic properties. Annealing processes for steel can be classified as follows: stress relief annealing, process annealing, spheroidized annealing, and full annealing. Normalizing. Normalizing is defined as the heating the steel to austenite phase and holding at that temperature for sufficient time followed by cooling it in air. Normalizing may be employed for any one of the following purposes: to eliminate coarse grain structures obtained in previous working operations such as rolling, forging, welding, etc. To modify and improve cast dendritic structures and reduced segregation by homogenizing the microstructures to produce harder and stronger steel compared to full annealing. To eliminate the carbide network at the grain boundaries of hypereutectoid steels and to improve machinability. Next, heat treatment process is hardening. So hardening may be defined as rapid cooling quenching of steel from the austenite phase. The rapid cooling is obtained by immersion of steel in water or oil bath. This rapid cooling of steel from austenite phase gives faster cooling rate than critical cooling rate of TTT diagram, and therefore a metastable phase called martensite is obtained. Martensite is harder than perlite, which accounts for the increased hardness of the rapidly cooled, that is known as quenched. To increase the hardness of steels for better wear resistance, to increase the hardness of tool steels to improve their cutting ability, to improve strength with sufficient ductility, to develop best combination of strength and notch ductility. So these are the medium of quenching and different objects which are quenched or immersed in this liquid. So before quench, this is a austenite structure, and after quenching, water quench and oil quench, these are the different or microstructures. Tempering. Structure of hardened steel is not suitable for engineering applications due to the following drawbacks. So martensite is extremely brittle and will result in failure of engineering components by cracking. Transformation of austenite to martensite induces high internal stresses due to thermal and structural stresses. These internal stresses can result heavy distortion and cracking of the part during service. The structure of hardened steel contains martensite and retained austenite, both of which are metastable phase and will change to stable phase with time. This change is accompanied by changing in dimensions and properties of steel, which is undesirable. So our hard material is again reheating, shocking and cooling to get the desired softness in the material after hardening. So after hardening, this process is known as tempering process, which is required to soft the material. Case hardening and surface hardening. If a component is to withstand conditions tending to produce wear on its surface, and the same time is to possess considerable strength to withstand forces acting on it. It is then usually made of a tough steel whose surface layer is hardened by any one of the following processes. So these are the surface hardening processes. First is carburizing, case hardening by carburizing. This is a surface hard by carbon and core will be soft. Nitriding, surface hard by carbon and core soft. Cyaniding, immerging material in molten salt, that is a sodium cyanide. Induction hardening, so in which a surface layer of steel subjected to eddy currents induced by a high frequency alternating current. And flame hardening, in which surface hardening by oxyacetylene high temperature flame. These processes are called surface or case hardening process. Hence, a surface hardening process is the process of providing through heat treatment a hard surface layer on steel piece with a tough core. So this is a microstructure of steel, and after a surface hardening, the surface become a hard, okay, and at the surface the perlite and cementite structures are possible. An internal part, core part is soft of ferrite structure. Heat treatment of aluminium and its alloys. The purpose of heat treating aluminum alloy is to raise their strength and hardness, improve ductility, and improve mechanical properties of both cast and wrought alloys. So there are three types of heat treatment process of aluminum. One is solution heat treatment, second is precipitation or hardening treatment, and third one is annealing. Now solution heat treatment for aluminum alloys. Solution heat treatment involves heating an alloy to a suitable temperature, holding at the temperature long enough to allow one or more constituents to enter into solid solution and then cooling rapidly enough to hold the constituents in solution. Solution homogenization treatments is used to minimize or eliminate the concentration differences, the segregation which occurs during solidification of an alloy. It improves the corrosion resistance of the castings. It improves the casting ductility, especially in ingots required to be worked later on. So this is the example of aluminum 4.5% copper alloy casting. So A is the coring and segregation due to rapid rate of solidification in sand mode. Okay, after solution heat treatment, rapid quenching retains the homogeneous or single structure. Precipitation treatment or aging are also known as age hardening for aluminum alloys. Aging produces a change in properties of a metal or alloy at a slow rate at room temperature and more rapidly at high temperatures. Age hardening. It is hardening by aging, usually after rapid cooling or cold working. Precipitation treatment. It is artificial aging in which a constituent precipitates working from a supersaturated solid solution. Precipitation hardening. It is the hardening caused by precipitation of a constituent from a supersaturated solid solution. So here is the example precipitation hardening in aluminum 4.5% carbon alloy. By this heat treatment process, we can increase the tensile strength and ductility of aluminum alloys. Third heat treatment process for aluminum alloy is annealing. Cold work such as rolling or drawing disturbs the original crystals of an alloy into a large number of smaller crystals. As the cold work processes, the metal or alloy is said to have strain hardened and the resistance to plastic flow of metal under stress increases. At this stage, it may become impossible to carry cold forming operation further in order to bring the object to final size or shape. Annealing, therefore, is carried out in order to soften the metal. Cold working may be continued further till the object or wire acquires the required size or shape. To remove the effect of age hardening or precipitation hardening treatment. Annealing will increase ductility and reduce the tensile strength and hardness of the metal or alloys. A heat treatable aluminum alloy may be annealed by heating it to about 400 to 425 degrees centigrade and allowing it to cool slowly in the furnace at a rate not exceeding 20 degrees centigrade per hour to 260 degrees centigrade. When cooled to 260 degrees centigrade, the material is withdrawn from the furnace and is cooled in the air. So this is about the heat treatment process of ferrous or steel material and aluminum alloys. Thank you very much for watching this video.